Hello, this is John from caveofprogramming.com, and this is the third in the series on Java multithreading from caveofprogramming.com. And in this tutorial we're going to start looking at the synchronized keyword in Java, and we're going to look at why you need it and what kind of problems you get with unsynchronized threads. So I'm in Eclipse, and I've got a class created here with a main method, and I'm just going to create an instance of this class because I want to give it some instance variables, and I'll give it a method called public void do work, just to have a kind of starting point to run. And I'm going to say app here.do work, so I'm just going to run this method in my main program. Okay, so in here I'm going to have some threads, a couple of threads that run, and I'm going to give app a private variable of type int, which I'll call count, and I'll set that initially equal to 0, although actually it would be initialized to 0 by default anyway because it's an instance variable. And in do work here I'm going to create a couple of threads, so I'm going to say thread t1 equals new thread. And using the technique that I showed you in a previous tutorial, here I'm going to say new runnable and open a bracket, and I'm going to give that a public void run method, and I'm going to put some code in run that's going to run in its own thread. So here I'm going to say let's have a loop, and I'll say for int equals 0, int I equals 0, I less than 10,000, and it has to be 10,000 to display the problem that I want to show you, or at least 10,000 or so, and I++. And in this loop I'm just going to increment count, so I'm just going to say count ++. Now I'm going to have another one of these threads, so let's just copy that, paste it down here, and have a thread t2. And then I'm going to start both of these threads, so t1.start and t2.start. So both loops are going to be running at the same time, roughly. And then I'm going to say sysout count is, and let's see the value of count. So we've got two threads trying to increment count 10,000 times each at the same time, so they're both accessing the same variable here. And then we display the value of the variable. Now you might already notice a problem with this code, and I'm going to run it and we'll see what happens. So if I run it, it says count is 0, and the reason for that is that here I start both of the threads, but start always returns immediately because it spawns a thread, an extra thread. That's kind of the whole point of it. So this executes, and then in the main thread this executes, and then this executes, and then after this these loops are continuing to run. So basically we're outputting the value of count before these loops have really had time to get started. So to fix that we need to wait until both of these threads have finished executing before we display the value of count. And of course we'll expect count to have a value of 20,000 because both threads are incrementing it 10,000 times. So to wait for the threads to finish, I can use the thread.join method, which literally just waits. It just pauses execution of the thread that it's called in, which is the main thread here, until the threads are finished. So join here won't return until this thread's finished, and then this won't return until this thread's finished. And these join throws are interrupted exception, so I have to surround with try catch, and let's put just both in the same try catch for convenience. Now if I run this, we've got count is 20,000, so you think, okay, my program's fine, but actually it isn't. Let's run it a few more times and see what happens. So 20,000, and here we've got one that isn't 20,000, it's 11,560. And you see sometimes it works, often it works, and other times it doesn't. And what's going on here? Why does it do that? The reason is that when you increment count, it looks like what we call an atomic operation. It looks like a thing that happens in one step, but it isn't. It's actually sort of equivalent to this. Count equals count plus 1. So there are 3 steps here, believe it or not. First we get the value of count, we get the current value. Then we add 1 to it. Then we add 1 to it, and then we store it back in count. So we're reading it, incrementing it, and then storing it back in the original variable. 3 steps. And in human terms, those 3 steps happen very quickly. But from a computer point of view, there's considerable time between each step, because the computer's continuing to do other things while this loop's running. So it's kind of like you fetch the value of count, then other things happen on your computer, and then you increment it and more things happen, then a bit later you store it back in count. And now think about what happens if 2 threads are trying to do that at the same time. Imagine that that count has the value 100, let's say. If both threads increment count, we expect it to be 102. But in fact, this thread could fetch the value of count when it's 100. And then this thread fetches the value of count when it's 100. This thread increments it, and then sometime later stores it back in the original variable. So count is now 101. Then this thread increments its read of the count variable from 100 to 101, and then this thread stores 101 back into this original variable. So the point is that both threads read the value of count when it was 100, and it could even be worse than that. Like this thread could read count when it's 100, and this thread might increment it twice in that time before this thread gets around to storing its incremented value back. So you can see that basically some of the increments are being skipped because both threads read the value when it's 100, let's say. And what we really need to do is we need to find some way of making sure that in that time when a thread reads the value of count, increments it and stores it back, no other thread can get at it and change it. Now the simplest way, actually, if you've just got a simple variable like this, a simple integer that you want to increment, would be to make it an atomic integer, because atomic integer is a specialized class that allows you to, it has a method that allows you to increment your count variable in one step. And you might think, if you've seen the last tutorial, you might think, well, declaring it volatile will help. And well, it might help a bit, but it's not going to fix the basic underlying problem, because the basic problem isn't really to do with caching. That might be an additional problem. It's to do with this interleaving. So to fix it, we need the synchronized keyword. And what I'm going to do is I'm going to create a method here, public void increment, let's call it increment. And in increment, I'm going to say count plus plus, and I'm going to change these to use that increment method. Now this won't fix anything in itself, so let's try running this. We've still got problems. But what I can do is I can say that increment is synchronized. I just add the synchronized keyword on here, and now when we run it, magically it's always 20,000. We've got rid of those problems with the threads interleaving. And what synchronized actually does is every object in Java, let's just close this console. I don't really know how to. There we go. Okay, every object in Java has what we call an intrinsic lock or a monitor lock. You could also call it a mutex. And if you call a synchronized method of an object, in this case we're calling the synchronized method of this app object here, you have to acquire the intrinsic lock before you can call it. And the thing is that only one thread can acquire the intrinsic lock at a time. And if one thread acquires the intrinsic lock and runs this method, and if another thread at the same time tries to call this method, then the second thread will just have to wait. It will just quietly wait until the first thread releases the intrinsic lock by the method finishing executing. So every object has one of these intrinsic locks, and only one thread can acquire it at a given time. And a method marked synchronize can only be called by behind the scenes acquiring the intrinsic lock, and that's why that fixes this problem. And you need to be aware of this whenever you've got multiple threads accessing shared data. And by the way, you don't need to declare this volatile now, because if you've declared, if you're running something in a synchronized block, then it's guaranteed that the current state of the variables in here, shared variables, will be visible to all threads, which is what volatile does. It just guarantees that all threads can see the current state of a variable, and Synchronized handles that itself. Okay, so that's it for this tutorial, and in the next tutorial in this series we're going to look at how you can use lock objects explicitly to improve and to make much more efficient code in some circumstances where by using multiple locks, because it's not always ideal to just use the one intrinsic lock that you have in your with your object, because often you want multiple locks to protect multiple different things that threads are doing, and we're going to look at that in the next tutorial. So this code is going to be on caveofprogramming.com, and you can also find the more free tutorials and some kind of premium paid tutorials as well if you're interested, on stuff like Java, web programming and Swing and various other things. So that's it for now, and until next time, happy coding.